Okay, hello YouTubers. We're going to make a wire antenna today for our SDR, and we're going to make a multiband. So I haven't seen anybody make one of these online, and I made it. I tested all of it. It works. I've got the math to show you. And well, let's get started. First of all, you need to get an LNA for your dongle. You can use this antenna with the regular dongle. You're just not going to pick up as much. These things are awesome. They have this version 3 of my dongle will power this LNA, and this is the 50 megahertz to 4 gigahertz LNA. I got it on Amazon, and it really improved my receive, so you need to get one of those. Okay, what we're going to do is take a multi-conductor wire. This is foam cord. I've used it. It tested it. You wouldn't think that smaller wire will work, but it does. Now we're just going to be making this for receive only. We can break some rules when making antennas because it's receive only, and I'll show you that, step you through all that. But what we need to know is how that signal works across this wire, and it's negatively charged, positively charged, and it flip-flops like this across your wire. And if you're not tuned, your wire is not the length that it needs to be for the frequency range, you're going to have a lot of problems. So you're not going to hear. It's going to just sit there with dead noise, static. Now, I've got the list that I made, and these are the links for a full wave for each meter and a quarter wave length for each band here, for each meter. So what this is going to do, we're going to start out by explaining how I put my antenna up. I put mine up on the eave of the roof. Basically, this is the house. I run mine out the window up to the eave, and this is where I started my antenna. I left a little end hanging down so I can plug it up. And then I attached it to the shingles going this way up to the eave of the roof. I got about 36 feet to there, from there to there, and I'm picking up everything in shortwave, medium wave, AM, all the way up. Really good on 80 meters, surprisingly, and I'll explain that. For how these quarter waves work and how that full wave works is, if you need 281 feet, if you're using 80 meters for a full wave. Now, you're not going to build an antenna 281 feet unless you're living in the city and you can drop a wire 281 feet down. But the full wavelengths are right here for making a wire, multi-conductor wire antenna. And the quarter wave lengths. Now, I'm using quarter wave lengths, okay, because that's your shortest kind of distance you can get with fairly good signal. These measurements do work. I've got my Cat 5 wire up, 8 conductor, and cut to different lengths, and I'm doing really good with this LNA and that dongle. I normally listen on 80 meters and 40 meters, and I'm hearing 5-6 different conversations you know, at one time, so it does work. I'll explain to you how we do this. We got our counterpoise way and our ground way. You can cross match these if you want. It gives you better signal. If you live in an apartment, HOA, you want to go this method because you can't get to a ground. This would be considered a dipole antenna, and I'll explain something on that because that one works. This counterpoise wire will take your noise away. Anytime you hook to ground, you're going to get better noise. So you're going to get noise away. So This is what I did. You take your wire, and we want to start out wherever you think you can start out. If you think you can go 70 feet, you'll be all right, because you're getting right into the range of the 80 meter band. If you can't start 70 feet, I couldn't. I was limited to the length that I could go. So I started at 36 feet, okay? So I laid out my wire along the sidewalk, measured out 36 feet. I cut it, and then I split the insulation back all the way back until I got to the next wire that I wanted, which was, you know, the green. And then I went to the next measurement, 25 feet. And what you're doing is you're staggering those cuts, but you're leaving that one wire there, okay? And then you're going down to the next one. That 25 feet, measure from your starting point, 25 feet. Split open the insulation, cut that wire. Go down to the next one. And then you're going to cut this wire, the next wire. And basically what you're doing is you're staggering those cuts to different lengths inside this shield, or inside this insulation. And if you can splice the insulation back and just get to the wire, you can snip the wire and then leave the insulation on. It'll help you whenever you get like this long wire by itself. It won't be flailing around out there. So basically what I did, I just slit with a razor the insulation back, pulled it back, found the wire I wanted, and took some really fine clippers and snipped it. And then that was my next length. And basically I went down all the way down here, but I want to stop you at about 12 meter, because if you look at these links, okay, you get down into 6 meter here at 5 feet, right? You start overlapping here, and what happens when you start overlapping, they start canceling each other out, and then you're basically working backwards the other way. And so if you, mine works, but I'm not getting anything on 6 meter for some reason. I'm canceling out, and I believe it's this 12 meter, that 40 feet, that's canceling me at the full wavelength. Because I'm at quarter wavelength, and that's going to fall right into that full wavelength, and that probably is why I'm not getting anything on 10, and I'm barely getting anything on 6. So my suggestion is you stay with about 5 or 6, and on the high HF bands, so you can get your short wave working, and get into 80 and 40 areas listening in on your ham. Now I'll tell you another way you can do it. You can make 2 of these. Make your 5 or 6 from here, okay, and then grab these 5 or 6, make you another wire, and then you can make you a box, pass-through box, put a switch in it, so that you can switch from one antenna to the other if you start streaming down the bands. But this is going to be way better, and it works tremendous on 80 meters and 40. It's great, and mine's only 36 feet at the longest wire, okay? So let's say you want to get you got your antenna cut, all right? You got it all laid out, cut to measurements. What we're going to do is how I did mine, I made a pass-through box so that I could ground it. Grounding is very important. If you don't ground while using this LNA, you're going to have too much noise. You're not going to be able to hear a lot. So you got 2 ways to do it. I come out my window right here to a ground rod that I put in. Now, you can get a ground rod at the hardware store. They're 8-foot lengths. You can get a 4-foot length. If you're dirt cheap, you don't have the money, what have you, you can use a tire iron. I seen a guy on YouTube, and he shoved a tire iron into the ground, wets it down with a bucket of water, and just used a clamp to attach his ground rod to. So, but it worked, you know. And what you're going to do is you're going to come out of your shack, and you're going to have to cut the end off at, unless you build a pass-through box where you can use coax connectors on each end. Some people may be smart enough. If you just like seeing this because you need an antenna that works and you don't know much, well, I'm going to show you. This center conductor is what we're using to go to our connector out to the antenna there. So basically, you're passing through from your radio there, that center conductor, and this shield right here is not used. Okay, you don't hook it to anything. It's grounded inside the box here by the connector, but I just snipped it off here. All right, and then all that is the center conductor. One wire. That's it. One wire. Okay. Now we got our antenna made. You got all the links cut that you need. Now you take that other end. All right. You just twist it together. I put a connector on it, and that's how you connect it up right there. Put you another connector, and then this will be where your starting point is. Now I'm going to give you some more advice when doing this, and then I'll give you these guys when living in apartments that can't get to a ground how to do that. You need to get this shield of this wire, right? It's coming from the radio, the SDR here. Okay. You need to get this shield wire right here to a ground rod. Okay. You can use shrink tube, what have you. Make this nice and waterproof. As long as you got a ground wire coming off that shield to that ground rod, you can take any wire you need that's shielded up to your antenna wherever you're going to start it. Okay, that's one way to do it. Now say you don't have a ground, right? You're living in an apartment. We got a counterpoise. Okay, you don't have a ground, so we're not going to do that. So we're going to do this. Now this is considered a dipole antenna. That's basically what it is. The counterpoise acts as gives the negative somewhere to float, so that you get the wavelength correct. Now you're going to make a dipole antenna just like this here. You're going to take your little connector, right? Connector up to that, or you can solder directly to that a wire, and you want that wire to be the same length, if you can, as your longest wire. So if you started at 36 feet, make a 36-foot counterpoise wire. But do this. Make it heavier gauge wire than what your antenna is. Okay? So if you're using Cat 5, I think that's 22, 24 gauge. Now go up to, you know, a 10 or 16 gauge wire. You know, that'll be a little thicker, and it'll help that flow. If you go the counterpoise way, you're just taking this hot wire right here directly to your antenna wire, the other end of your antenna there, and that's your connection. This is here, go out to another wire, and you can coil. This wire needs to be straight. This wire needs to be like that, straight. Okay, don't let it all coil up like that. You're going to lose reception. This wire needs to be straight. This wire, the counterpoise wire, doesn't. You can just coil it up, maybe throw it down the hallway in the house, whatever, you know. If you can't get outside, you can string this across your room of your house, across that ceiling, whatever, maybe get in the attic, you know, and it works. It'll work that way also. But just leave your counterpoise wire away from this wire. Okay, you're going to drop it out a window, right? You live in say you live in a 3-story apartment there, right? You got a window there you want to drop that wire out of, hang it down, put a little weight down there, and let it hang. Your counterpoise wire, right? That counterpoise wire stays in the apartment. Do not run that counterpoise wire down there with that. That's a no-no, okay? That's bad. And another thing, if you leave this wire hanging out in the wind, do not leave it hooked up to this. it will burn this up. This is an ungrounded antenna, and you'll get static electricity, static coming from the wind blowing across the wire, and it'll backfeed into this and blow it up. So if you do a counterpoise method, that method, you unhook that every time, unless you can get it grounded and give it somewhere to go. Okay, so if you live in an apartment, you're going to use this one. If you can't get to ground, you're going to use this one. If you can get to ground, use this one. This is your best option. Okay, you take that shield of the wire down to the ground rod. If you got to run a length of wire to get to there, that's fine, but you do it on the ground. Don't take your ground wire up. No. So you get that coax down there to the ground. You get a lightning resistor, that'd be your best bet. If you want to spend some money, get 20 bucks, 25 bucks. You can get an MFJ lightning arrestor, I think, on Amazon, and that works real well. Then it gives you a cable connection at both ends. And that's what I did basically with this. So I just made it myself, but that should help you get going with your SDR antenna. Just make your antenna, you know, cut them wires at different lengths inside there. Leave as much insulation on as you can. That way you won't have to use shrink tube to keep the wires together as you go out. You'll have a lot of money in shrink tube. Now I'm going to show you another little trick. So you got your antenna, your counterpoise, or your antenna wire coming out, okay? And you get it, you got your lightning arrestor down here maybe, or you're just going directly to ground, you know, however you're going to do it. You're taking that shield wire to the ground, okay? That length that you use to take that center connector up to the antenna right there, that length of wire right there, do not use regular wire. You need shielded wire. If you can, try to use coax. Get that length to your starting point of your antenna, and there's a reason for that, and that's because when you get up here, if you want to add these in on yours, you're only going 2 feet. Well, you don't want to go 2 feet off the ground. You don't want to go 2 feet from here. You want to try to go 2 feet from here, you see. And that way if you stay in this area here, you're going to bring noise into your LNA or your dongle, either one, and then it's just not going to sound good. Okay. Now, with that being said, you can do it in a couple different things. This being this counterpoise way, okay, is considered a dipole antenna. Now you can buy a 9-to-1 balun on eBay, Amazon, and they can be small or they can be a big giant one that like fit in that box right there. It'd be huge, or you can get a smaller one. Because we're receive only, this is receive only, okay. You can put one of these 9-to-1 baluns on anywhere in your system here, right here, okay, and that'll help that'll help bring in more signal, because you're balancing your antenna, so to speak. You're letting that balun help take this to 50 ohms, because a regular wire is not 50 ohms, and it's unbalanced. And a balun, or you can also get a choke, because it's receive only. That choke will help too. Either one. You can try one, try the other. If you got the money to buy a $13 balun or a $10 choke, tell you how to wrap the choke, the wire around the choke, and it helps if you use this counterpoise method. I tried it on the ground. It didn't really seem to help. I think the dongle there is taking some of that away. I'm not for sure. I didn't test that, but I tested a lot of wires and a lot of length of wire off this, and I climbed up there, cut little different strips out, to try to get you the right amount of length here. And these are about the best measurements. So this is what I run mine at, 36, 25, 8. Right here I had to change them. The calculator that I used to calculate the full wave, cut to quarter wave and all that, it set a different number for these, and it didn't work. So I had to shorten them. So with that being said, it seems to work okay on 20, and I don't think anybody talks on 17 here, because I've yet to see anything on there. So kind of wondering about that one. If you want to make 2 of these, okay, start with your 7-inch antenna and work your way up, so that you have like 9. I think I went to 10.5 and made one, so I made 2, this and these. Okay, well, that one actually. And I put a switch on a box so that you could just switch the wire. You know, it's just a regular automotive switch, and because you're only receive here. You don't have to worry about transmit, okay? And because you just need connection, that's it. And you need something that doesn't add noise, okay? So that's the reason why I tell you, if you're going to run from a ground rod, that little short distance from the bottom of up to where you're going to connect, that needs to be shielded wire. So if you have a wire anywhere in your antenna, okay, no matter how you're going to wire it and how you're going to do it, you need to run this with a shielded type wire. Now you don't have to ground it. It's just shielding that inside wire from noise. That's all you're doing, because all we're using is that center wire. This is really just going to ground or to counterpoise, either one. This is where all your receives coming from. So you don't want you want short connections. If you got exposed places, you want short connections. And I'll show you another little trick. Say you want to put this wire up on your roof, right? Okay, here you go. You take this tie wrap, you get it cinched around that wire just to where you can still move it. Okay, to where you can still move it. You take this length of the excess. I had to cut mine off a little bit to get them in there, but you go right in between those shingles, right there. Slide that in between those shingles. You won't allow water in or nothing. You're just going in between that little gap in the shingle, right there in between the gap where they overlap. And you slide that in. It'll actually lock it down enough, and then you super cinch it down once you get it tight. And go up to your next one, it'll be nice and tight. And then you go slide the next one into the roof and then tighten it down. Keep going. My wire's been up there for 3 weeks and it's still the same tightness. It hasn't sagged or nothing. But whatever you do, don't let your wire have gaps and loops in it like that. You want it kind of tight. The counterpoise wire, it don't matter. You can figure out a way to wind it up or throw it out real long, whatever. That don't matter. But this wire, the main wire, your antenna wire, needs to be solid. Okay, needs to be at least flat. And you want to try to go vertical. We want to go up with it. Throw it up in a tree. Drop it down. You can even run your coax directly to it if you want, right? Run your coax directly to your antenna, and then have your counterpoise wire strung up, or run your ground rod in by a tree there and connect that down to the ground. And you're good to go. Or like I said, you can toss it out a window, you know, let it dangle. It don't know it's upside down. So it'll be a nice, it'll catch those nice waves, you know. So this is cheap. I think I got this for $10 at the hardware store, and it has 4 conductor. You can get Cat 5 cable. It has 8. It's 8 conductors, network cable, and it's some of it you can get solid wire in there versus stranded, and that solid wire seemed to be a little bit more solid on single. I noticed, than the telephone cord. Maybe just because it's so thin. But this does work. Telephone cord does work. I'm testing one right now. So I'm going to leave this up here because you need to write that down, or you want to look, you know, look up, you can find a calculator online, but what I did was, where this 2 meter band is, it's huge. It's quite a bit of, you know, so I went right in the middle of that band for this measurement. Okay, so if it like 17 meters, it's pretty small, it's pretty dinky, so I just started right at 20, you know, 20 meters, 17 meters. But in them bigger bands, especially on 70 meter, I went right in the middle and then calculated the length from that. That's what the calculator calculated, and I tested it. It works. You got 7 inch, 1.5 inches, and what I would do, I'd make one from 10 meter up here, put it on a switch, if you can. That way you can just flip the switch and flip back and forth, or get you an antenna switcher. That works too. You can get a cheap antenna switcher, but if you're running this counterpoise, unhook this from if you're going to leave that the main antenna outside there, unhook that from your LNA. You will have problems. If you will burn that up, and you will burn up your dongle if you leave it directly to your dongle too, because that's picking up RF, and it's picking up static electricity, and it's shooting it through that wire back into this SDR. So keep that in mind. If you're running a ground, you shouldn't have to worry about it. It's got someplace to go. But with that being said, I hope you try it out. You can get you a balun or a choke for this counterpoise. You can also put a balun or a choke on this. It does help on a ground system. I'm ordering another one, a smaller one from Amazon. I think it was like $16, and it's got just a coax connector on it like that, and 2 little wing nuts on each side for connecting wire. And I'm just going to set it in my box here. But you can make this box if you want. It's literally a pass-through box. It's two connectors, SO239s, and then the center conductors are connected together, and then the shields are connected inside to the ground. And this is a ground that this sits on my ground rod like such, and allows me to attach the ground wire from the ground rod over here to get our ground, so we take our noise out of our wire antenna. Okay, now if you get an 8 conductor wire, this is only 4, that'd give you 4 bands. Okay, that 8 conductor wire, you get a few more, but you're going to run into cancellation if you go too many. I did notice that, so I would limit it to about 4 or 5 per wire, and run 2 wires. You could almost put them together. So with that being said, I hope the counterpoise and the ground method helps you out on making a wire antenna, because if you just stick a wire directly into that, you're going to have so much noise. Even if you put it into your regular dongle, you're going to have so much noise, it's terrible. So just a cheap wire, you know, get you some connectors to connect your ends, and maybe just tape if that's all you got. You know, have at it. That'll get you on your SDR, and that'll get you listening. So with that being said, I hope this helps, and 73's